Doing 13.5 graphing linear equations in standard form. So in our last lesson we talked about slope-intercept form. That's when equations start with y equals, and our formula there is y equals mx plus b. Today we're looking at a different form of linear equation. So when it looks like what this one is right here, it has a number and an x and a number and a y, and then another number on the other side of the equal sign. That's called standard form. So our general formula there is ax plus by equals c, where a and b are not both 0. So we have to have our x and our y there together on the same side of the equal sign. That's what makes it a standard form equation. Okay, so here's our first type of problem. So they've given us an equation in standard form. It says graph negative 2x plus 3y equals negative 6. And they're asking us to rewrite it into slope-intercept form and then graph. There are a couple different strategies we're going to look at today for graphing things that are in standard form. But this is our first strategy, rewriting it to slope-intercept form and then graphing it that way. So let me show you how to do that. So we've looked in the past this year how to solve equations for y, and we did a little of that in the last lesson as well. But if we need it to be in slope-intercept form, it means we need to get y by itself. So I started by getting rid of the 2x. This was a negative 2. I added a positive 2. Negative 6 plus 2x. Slope-intercept form, you see that variable first. So instead of writing negative 6 plus 2x, I wrote 2x first, and then minus 6. Doesn't really matter. It could go either way. And then I have this 3 in front of my y. I have to get it by itself to be slope-intercept form. So times 3 divided by 3. All of the terms have to be divided by 3. And then I simplify that. So 3 divided by 3 is 1. So I've got 1y. I have 2x divided by 3, and so I'm going to take that 2 divided by 3, I'm going to push it out to the front and make that look like a fraction, 2/3. And then negative 6 divided by positive 3 is 2. So there's my equation. Y equals 2x, y equals 2/3 x minus 2. That's my slope-intercept form equation. Now I'm ready to graph it. So my y-intercept here, now that's in slope-intercept form, is negative 2. So on the y-axis, I go to where negative 2 is, and I graph it. So that's right here. That's where my y-intercept is hitting that y-axis. And then 2/3 means I'm traveling up 2, and I'm traveling over 3. And that gives me that second point. And those 2 points, that's all I need to graph is 2 points. More points are better. I could go up another 2 and over another 3 if I wanted to get another point to go on that line. But as long as I have at least 2 points, I have enough for my line. I connect them, and then I have my straight line. As always, when you're graphing, you want to make sure you extend that line all the way through the graph space with arrows on the ends. Okay, so these are 2 for you to try on your own. You're going to use the same strategy that we did in the last one, which is to solve the linear equation for slope-intercept form, and then to use the slope and the y-intercept to graph them. Go ahead and pause the video and go ahead and try these 2 graphs. Okay, let's check your answers. All right, so for number 1, x plus y equals negative 2. I subtracted x on both sides. I wrote that part first since it's slope-intercept form. So I have y equals negative x minus 2. And so when I graphed it, that minus 2, that's my y-intercept. So I went down to negative 2, and I made my point there. Here it is right here. And then I used my slope. Negative x means negative 1. That means going down 1 and over 1 to that next point, which for this particular graph is 1, negative 3. And if I wanted to, I could continue to go down 1, over 1, and so on to make more points on the line. 2 points is all I really need, but I could do more if I wanted to. Line should be all the way extended through your graph and arrows on both ends. 2 is a little more tricky, a little trickier. Negative 1/2 x plus 2y equals 6. So I started by adding 1/2, positive 1/2, because this is a negative 1/2 x to both sides. So then I got 2y equals positive 1/2 x plus 6. To get rid of the coefficient of 2, I divided them by 2. When I did 1/2 divided by 2, I did my work down here. 1/2 divided by 2, keep change flip, is like 1/2 times 1/2, which is 1/4. So I have y equals 1/4 x. And then my 6 divided by 2, I got 3. So I have 1/4 x plus 3 as my equation. So 3 is my y-intercept. So on the y-axis, I started at 3. 1/4 is my slope. So I'm going up 1 point. I'm going over 4 to my next point there. So my second point is at 4, 4. And then I just connect those two with a straight line going all the way through that graph space. All right, so that's one strategy for graphing equations. So I'm going to show you a different way that can be helpful for graphing equations that are in standard form. Now, it really doesn't matter when we get to an assessment or a test. For this chapter, you can choose whatever strategy you want for graphing things. But if it's one like this one where it asks for extra information, then of course you have to find that information before you make your graph. You just don't have to make the graph using that. So it says graph x plus 3y equals -3 using intercepts. So what that means is they want you to find the x and y intercept, and they want you to include that on your graph. So to find our x and y intercepts, we're going to be solving for x, and then we're going to be solving for y. All right, so let's go ahead and take a look at that. So to find my y-intercept, I need to set x to be 0. So I take 0 and I put it into the equation. So instead of x plus 3y, now I have 0 plus 3y equals -3. Then I just solve it like I would any other equation. This is a times 3, I divide by 3. -3 divided by 3 is -1. That means on my line is going to hit the y-axis at -1. That's the point 0, -1. It's right here. Then I do the same thing and I solve for y. So now instead of putting in 0 for x, I'm putting in 0 for y. This is going to give me my x-intercept. So when y equals 0, I put in 0 for y. 3 times 0 is 0. So all I'm left with is x equals -3. That means I hit the x-axis at -3. So my x-intercept is right here. X value is -3. When the y value is 0, that's where that order pair comes from. And then my y-intercept is where it hits the y-axis. And again, I got that from getting x is 0, and we solved it to get y equals -1. So on the y-axis, -1. And then you have those 2 points and you graph it. And connect it with a line. Line goes to the entire graph space. All right, here are 2 for you to try on your own. So this time we're going to practice using our x and our y intercepts and using that to help make the graph. Go ahead and pause the video and try these 2 on your own. Okay, let's check our answers. Okay, so for number 3, I have 2x minus y equals 8. And here's what my graph looks like. I'm going to move this up a little bit. Okay, so when we put in 0 for x to get the y-intercept, we have a -y. That minus is like a negative. -y equals 8. We divide by -1 to get y equals -8. And then, so my point here is at 0. Gosh, that looks like a -5, but really is an 8. 0, -8 is my point. So on the y-axis, -8. That's that point right there. Then I did the same thing for y equaling 0. So I put in 0 for y up here. I was left with 2x equals 8. When you divide by 2, you get x equals 4. That means on the x-axis, we're putting on the point on 4. And then once you have those 2 points, you can connect them with a line. On my second equation, x plus 3y equals 6. We start by putting 0 in for x and solving for y. So when x is 0, we are left with 3y equals 6. We divide by 3 and we get y equals 2. And so our order pair there is 0, x was 0, y is 2. So my y-intercept on the y-axis, the line hits the y-axis at 2. And then for my x-intercept, we take 0, we put it in for y. So 0 goes in here. 3 times 0 is 0. So really I'm just left with x equals 6. There isn't anything else to solve there. That means the x-intercept where it hits the x-axis is right here at 6, 0. And then you connect those two to make your line. All right, let's take a look at a story problem here. So it says you have $6 to spend on apples and bananas. Graph the equation 1.5x plus 6/10 y equals 6, where x is the number of pounds of apples and y is the number of pounds of bananas. And then interpret the intercepts. So they've asked to do a couple things. First thing, we need to graph. They don't tell us how to graph. You can graph however you want. But since B says interpret the intercepts, it makes sense to go ahead and use our intercepts to help us graph. Just like in any story problem graph we've done all year, you do need to make sure that you have a title and labels on your axes. So I put the title cost of fruit up here on the top. I have bananas on my y-axis. I have apples on my x-axis. Then I took my equation up here, 1.5x plus 6/10 y equals 6. And I wrote, substituted my values. So bananas were 60 cents a pound. That's where the 6/10 comes from. Bananas are my y. And then apples are $1.50 per pound. So that's the 1.5 on the x. So I put in 0 for x. And then I had 6/10 y left equals 6. Divided 6 by 6/10, and I got 10. So on my y-axis, I numbered it, I went up to 10, and I made my point. That's at 0, 10. Then I did the same thing just for y equals 0. So when I put y equals 0 into this equation, that cancels out this part. It leaves me with 1.5x equals 6. I divided by my coefficient of 1.5, so 1.5 divided by 1.5 gives me x. 6 divided by 1.5 gives me 4. So on the x-axis, I'm going to put my point at 4. This is not an example of connect the lines and extend through the graph because it's a story problem situation. You're not going to have negative amounts of apples or bananas. We only have one quadrant graph, so we're only extending our line within that graph. Okay, so that part is all of A, but B says interpret, which means to explain. So if I scroll all the way down here, here's where my explanation is. It says you can buy 10 pounds bananas and 0 pounds apples. That's explaining what my y-intercept means. Or you can buy 4 pounds of apples and 0 pounds of bananas. So that's explaining what these two ordered pairs 0, 10 and 4, 0 mean. All right, so for our last one here, if in example 3 you buy y pounds of oranges instead of bananas, oranges cost $1.20 per pound. Graph the equation 1.5x plus 1 2/10 y equals 6. That's y there. Interpret the intercepts. Go ahead and pause the video and try this one on your own. Okay, let's check your answer. Okay, so you need a label at the, title at the top. I put cost of fruit. You need a label on your x and y. So I have oranges here on the y. I have apples on the x. And then you need to find your intercepts. So to put in x is 0. We get 1.2 y equals 6. We divide by our 1 2/10. 6 divided by 1 2/10 is 5. So I put my point on the y-axis here at where 5 is on the y-axis. And then I substituted y for 0. I was left with 1.5x equals 6. And then I divided both sides by 1.5. When I did 6 divided by 1.5, I have 4, just like you did on the last problem. So 4 pounds there. And then I need to interpret, which it looks like I forgot to write down, but an interpretation for this one would be that I can buy 5 oranges and no apples, or I could buy 4 apples and no oranges. That would be my interpretation.